Hello, good morning. It's August 22nd here, and I'm ready to take another run at this guy, this very complicated guy here. Holy smokes. So what I've done this morning, because I've been working a little bit before I turned the cameras on, I wanted to find some kind of troubleshooting spot that I could start from, get a grip on something that clearly is not right, and then go from there. So what I focused on is the output of the sweep generator, not the marker generator, the sweep generator, which doesn't seem to be working. And on the scope there, you're seeing the output of the sweep generator right now on the plate of the, not the plate. Here we go. There we go. Okay, so I'm on the cathode. Let's double check this. It's been a few minutes since I've been in here. So we're on pin 3. Pin 3 of the 6BQ7. Pin 3 is basically the cathode follower output. That would be the load resistor, I guess, or the cathode resistor, you could call it. So the output from the sweep should be right here on pin 3. Pin 3 is scoped, and you can see it's flat as can be. So there's no output from the sweep oscillator. Okay, so the next thing I wanted to do was check some voltages. Bring back the manual. There's a nice voltage table here. I even went so far as to make sure the tubes are in the right sockets. That's how that's how far out I've gotten with this. And they are. The right tubes are in the right sockets. 6BQ7, there's 150 volts on pin 1 and about 100 volts on pin 6. 150 and 100, 1 and 6. So we're going to look at pin 1 first. I'm on the 150 volt scale, and we're looking for 150 volts on pin number 1. This is pin number 1. Make sure that's set right. And we get 100 volts on pin number 1. Then we should be looking for 100 volts on pin number 6. 1, 2, 3, 4, 5, 6. Here's pin number 6. And we should see 100 volts there. There's nothing. Well, that's a pretty good troubleshooting spot to start, I think. Having found nothing there. Is this really what I think it is? It's definitely the 6BQ7. And 1, 2, 3, 4, it's definitely pin number 6. Pin number 6 of the 6BQ7. Pin number 6. Pin number 6 is the plate. So, so this is an oscillator here. This is the amplifier of the oscillator. That's how I understand this. So this has to be amplifying to some degree. The plate has to have some B plus on it, doesn't it? Pin 6 is supposed to be, yes, of course it is. 150. I don't need to look at the chart, I remember. 150. Where'd the chart go? It's got to be at the end because you have to have the unit built to do these tests. There it is. Double checking everything here. 150 volts, pin 1, 6BQ7. And 96 on pin 6. So we're getting a little bit on pin 1 and next to nothing on pin 6. Next to nothing, really nothing. There's tiny, tiny voltage on pin 6. Okay, that's our starting point. That would be the starting point for this. What's going to be the ending point? Who knows? Pin 6 is supposed to have 96 volts there. Now, the mystery to me, it's a real mystery. What is this? Red looks like a jumper, yellow looks like another jumper, jumping something. as if maybe this is one circuit board and this is part of another, not circuit board, but circuit area, or like there's a plate here, it's a plate here, and then underneath there's a bunch. Maybe that's what they've done. Maybe they're trying to show that separate there. And there's two wires that run between this part and this part. But that can't be the case, because the socket terminal here is soldered directly to the capacitor terminal here. There's no wire. There's no wire, there's no yellow anything, there's no yellow or red anything in here. There's nothing that matches this strange arrangement. I don't know what that is. I really don't. So the best I can do is ignore it. Okay, so we ignore that. We should find, well, here's a 22K resistor, and on the top side of it, oh boy, yikes. There's some complicated stuff going on. There's a lot of complicated stuff going on in this nifty little machine here. There's a blanking thing going on. And the blanking is generated by this. This is a stabilizer trying to hold the output level. I believe that's what this is doing. I think. The oscillations are taking place between the tunable capacitors and this coil here. This is a very, very special transformer. This has actually got a peculiar name to it. It's called I'm looking right at it here. Incremental inductor, and it's a very special guy. We looked at it before, but let's see if I can spin this around. I can't spin it around anymore. Too many wires tangled up. That's this black thing here. The whole thing is coated. They dipped it after they built it. So, but in here is a bunch of coils. One of the coils, you pass a current through it. This might set up a current in the other coils. It affects, basically what they're doing is they're fooling around with the amount of saturation in this transformer. And when they increase the saturation, it changes its inductance. And they do it by passing a current through this part. This is all part of one thing here. Exactly how it works, I don't know, but suffice it to say that much. This is the controller sweep width. This is controlling how much current is flowing in this winding, which is controlling the overall inductance of this circuit. That's kind of the idea. It's very clever stuff. I think I said before, before this technique was developed, doing something to make an oscillator vary in frequency is very, very tricky stuff. Very tricky stuff. One technique was to use a tube as a variable reactor. So with tubes, their reactance is based to some degree on the potential of the different elements. So if you get the right tube and fool with it in the right way, you might be able to turn it into a variable reactor of some sort, capacitor or inductor, probably a capacitor. So that's another technique that you can use to generate a variation that will lead to a frequency modulation of a signal. This technique comes along with the added benefit that you can range the sweep hugely doing this. You get a huge effect in this, I guess. And the result of that is that this thing has a gigantic sweep, a ridiculously huge sweep. It'll sweep almost the entire fundamental frequency range it's putting out. So in other words, you're putting out 100 megahertz, you can practically sweep, well, you can sweep 60 megahertz. That's a huge sweep. That's one of the reasons why I want to get this guy going. There's some interesting things that can be done if you can sweep through a big enough range of frequencies. And why am I doing all this talking now? Because we're going to look for why would it be that there would be no voltage or very, very low voltage here. And my suspicion was this thing, but I don't know what that thing is, so can't do much about that. And so 22K resistor. Oh yeah, I was going to get up to the top here. Oh, this got me around all this stuff. How does any kind of voltage get on here? Well, it must be coming through all these. There's voltage here, plate voltage. This is the plate. Doesn't quite make it over. Doesn't quite make it over here. Well, it could be coming up the other side of the power supply, coming up here, here. No, that's driving into all this stuff. Well, maybe this is what happens with this tube controls the voltage at this point, which controls the voltage on the plate. So maybe this is exactly how this tube works. It's controlling the plate voltage up here. You have bad plate voltage up here. Is it because of this? Don't know. We need to find this point and see what's there. Even find this point and see what's there. Pin 6 of the 6CL6. Let's go right there. Pin 6 of the 6CL6. Pin 6. If we look at the table now, pin 6. Come on. 6CL6. Pin 6. Pin 6. Pin 6 should have 100 volts. Hey, that sounds familiar. Okay, pin 6 of the 6CL6. This is the 6CL6 in there. Going around too many times. I can take this off now because it's showing us nothing anyway. There's nothing to show. Pin 6 of the 6CL6. Pin 6. Pin 6. Okay. Right up in here, pin 6. So we start with pin 1, 2, 3, 4. Pin 6. This would be pin 6. So we're on a 150 volt scale, 100 volts up here. Pin 6. Get that same low voltage. Pin 6. Pin 6. So we tested here. We have a low voltage. So this is a complicated deal, and I've read about this only once. I really haven't tried to figure out exactly what they're doing because it's complicated what they're up to here. You can just guess that the more current flowing in this tube, the more voltage drop in here, the less voltage is left here. What am I hearing here? I'm hearing the overhead lamp. That's what I'm hearing. Any little buzz or noise. I think something's catching fire. No. So what? Problems in here? Oh! Wow. It's pretty sure to be a chunk of voltage there. A chunk of voltage. By the time you get here, you're left with pittance. I hate looking at things like that, thinking about them being open. Now, if that were open, 150K, oh boy. Okay, let's not jump to conclusions. So we need to work our way up this chain. We need to find the top of this. It's not, I certainly know where that spot is. We could start there just to reassure, just to make sure that what I think is true. We need to find this 30 Henry, 50 milliamp choke. Now, I think there's only one choke in here. That would be this great big honker up here, this guy. He's warm. He's warm. He's warm because he's doing something. If that's the right thing. Where did I go here? So if it is, there's a 150K resistor across the leads, and there's the 2500 that I've been looking at the whole time. I'm wondering why. So there's voltage on this side, I've tested it before, and very little left over. There's a fairly heavy current flowing down here. Now would that be because of problems in the control circuit of this tube? So pin number 9 or 2, 9 or 2 should have some kind of grid control voltage on it coming from over. Wow. Yeah, coming from over there. Well, let's take a look and see what the table says about 2 or 9 on the 6CL6. 2 or 9 on the 6CL6. 2 or 9. 6CL6, 2 or 9 minus 2.4 volts. That's a grid bias voltage. Let's take a look at that, see if that's really there. 2 or 9 on the 6CL6. 6CL6 is there. 2 or 9. Okay, but negative. I'll drop, make my meter a little more sensitive. 2 or 9. I'm going to let you watch the meter. Pins 2 or 9. They are two has no connection. 2, 1. We'll go the right way here. I'm sorry, we discounted this wrong. Go the right way. 2 has a connection. 2 is here. So again, so I got the meter on negative. We're on the 15 volt scale. It's just under 2 volts. So it's close to what it should be. It's there. It's in the right direction. It's not quite what it says here, but then that could be because of the way I've got things set up here. Maybe if I turn some controls, it would change. So we think this is okay. And this is not okay. We need to look at the top of this. We need to look at the other side of this resistor. Because maybe current is getting through this resistor, but not through the coil. The coil's warm. It's warm. Well, the resistor's open. So let's just go up through the circuit here. So we'll start right at the bottom of this resistor. On the other side of the resistor, find the 150K and go up there. Okay, so we're going to start with... Oh, wait a minute now. What have I just done here? It doesn't take long for me to get confused. That's for sure. Right. Right. 2, 6. No problem. Okay, so this is pin 6 again. Right here. This is the pin 6. We should have 100 volts, and we have on the 50 volt scale 25 volts. The top of the resistor, the 2500 resistor, just having some trouble making contact there. Let's try it here. So the top of the resistor, so we're on the 150 volt scale. We got 130 at the top of the resistor. 130 here. It just sounds like way too much is dropping in this resistor. The 130 here, up above here, should be like 220. So if this is pulling current because something's going on somewhere, it's pulling current through this guy. And that's why he's getting warm. Not hot, just getting pleasantly warm. Okay, so top point 130, find the 150K. Find the 150K. Okay, it's right there. It's the easiest eye to see. Brown, green, yellow. Okay, other side of the 150K. Puts my meter right over Okay, so now it's 180. I'm reading 180 volts. That voltage that I just read, wow, 180 here. It's a wire back to here. Now why is it? I think I'm reading 220 on this side. Let's go back and check that. Resistor. So that resistor is a 4D, what was it? 470. 470. Here it is right here. What's going on here? Am I mistaken? Isn't this where I've been? So this used to be 220. Isn't this always 220 here? Now it's 180. It's another indication of a large draw. You want to see another indication of a large draw? This light is on. I'm not sure that's correct. And if we attempt to measure the wattage, and I don't know what the wattage is supposed to be here, this meter's not going to be accurate the way I've got it set up, but it gives a reading of 175 watt scale, about 40 watts. 40 watts. Somewhere it's going to say in the manual what the wattage of this thing is, but I'm not going to look for it right now. Ooh, watch where you stick your fingers there, Jim. It's definitely warming up. In the long run, it might get too hot. In the long run. So we got a number of suggestions here that say there's too much current going through this tube. Screen voltage, I didn't check that. Ooh, pin 3. There's a 2 water resistor there too, so it expects heavy action on pin 3. Heavy current, pin 3. Okay, we'll check pin 3. Pin 3. 500. Pin 3, 1, 2, 3. A great big resistor sitting there. You can see it in the camera right here. What did we get there? We got up to this point on the 500 scale. 120 volts. I'm not really, just don't seem to be I just don't seem to be adding things up very well here today in my head. 120 volts? Almost the same on both sides. That's 180 on my meter, and this is slightly lower. This must be the second side. This must be the first side. 180 exactly, and then if we want to find that same 180, it's at the top of the little resistor here. We should see exactly the same thing here. Yeah, 180 exactly the same. And then on the other side of that resistor, 180 becomes 130. Now we're down to 130. 130. And the voltage that's missing is supposed to be 100 and 150. And what we've got should be 150 and 100. And what we got is 100 and 0. Or nearly 0. So the 150. I can't think very well this morning. Staying up too late last night or something like that. Yeah, we had company over last night. That's the first time we've done that in well over a year. Just outside on our deck. Just a couple friends of ours that we know well. It's really kind of weird sitting out there with people. Very strange experience. Okay, maybe I should stop and take a little break here, let my head settle down, because it really isn't working well. I'm only on like the first third of my cup of coffee here. Okay, screen voltage on the 6L6. The screen is pin 3. Pin 3 is 1, 2, 3. Oh yeah, screen with the big, didn't I do this? Maybe I'm doing the same thing over here. 500 scale, so we got 130 there. 130 screen. And what's it supposed to be? Screen on the 6L6. Pin 3, 150. And 100 on pin 6. 150. So 150. Well, if I put it like this, should be full. It's 125. Short a bit. Now, what are we supplying the whole thing with here? Oh my gosh. Uh-oh. Hey, hold on. Something's going on here. Something definitely is going on here. Didn't check this. I should have checked it right away. I just assumed there wouldn't be a problem. I did notice the lights are fairly bright. 87 volts. We're running this with 87 volts. Oh my, what am I going to do now? 87 volts. It's been running for an hour and a half here. This temperature feels stable. Doesn't feel like it's getting any warmer. Well, this is a stupid situation. Again, if I raise it up to a full voltage, then maybe the whole thing will come to life. Could it be so stupid that all this time I've been operating it with too low a voltage to operate? No, I can't imagine I'm that dumb. You probably can, but oh my gosh, what do I do? Turn it up, see what happens. Turn it up, monitor the, let's find out what is the proper wattage on this. Let's get that straight. And we'll find out if there's something here to panic about or not. Oh my gosh, where am I going to find that information? They put it right here, right in the very beginning. So I'm going to have to go hunting for the wattage. There it is, 50 watts. I found it, 50 watts. 50 watts. And we're going to measure this a little more carefully. This guy is going to feed a voltage which is dropping through those lights to get to here. This guy will do a calibrated wattage reading if 120 volts is sitting here. 117 rather. So I need to make sure this is right on the right voltage. You don't have to worry about all this stuff. Here, you push the button, read the wattage. Okay, we're on the 175 scale. It's 175 watt scale. So we're just under 50 watts. Okay, so we can watch that scale, and I will throw full power on here. I'm going to flip the switch. It should rise just to 50. So if it goes way up to 75, 65, 65. What do you think? Think that's a problem? 65? It's 15 extra watts somewhere. Okay, for sure this is going to get hotter now, but it's going to take some time. So let's take a look at, remember I said, hey, what's going on with the power supply voltage? Why is it low? Now we know why. Now we know why. Then I get back to the 220. Oh my gosh, what stupid things I've been doing here all morning. 220. So now if we go back and look at the two voltages that should be Where was I reading? I was reading one. It was supposed to be 150. I was reading 100. What tube was that? What tube was that? Oh, son of a gun. Really losing my mind here this morning. Just, okay. $150 on the 6 CL6. 150. Well, I'll tell you, I just think 3 and 6. Pins 3 and 6. 3 and 6. Okay, pin 3. I'm remembering everything now, sort of. Yeah, 3. Here's 3. Now that's supposed to be 150. Let's put this right on the 150 scale. I think it's going to go right over. So it's more than 150 there now. Wow, we've really made an improvement. And the other pin, pin 6, should be 100. Pin 6. So we'll go on here. 1, 2, 3, 4, 5, 6. Pin 6. Okay, we're on the 150. Oh, 150 volt scale, and we're only getting 40 volts on pin 6. 40 volts on pin 6. I think we have a winner. 40 volts on pin 6. So 40 volts on pin 6. Supposed to be 100 there, and there's only 40. Now, is that because I got some settings set somehow? Let's see what it says here for this table to work. Line voltage 115. 116. We got 116 coming onto it now. Voltage from terminals. Unless otherwise indicate, all voltage positive. Measure the camera. Voltage taken a Heathkit 11 mega ohm VTVM. Hey, I'm using a Heathkit VTVM. Bias voltage across primary inductor terminals 6 volts on bands A, B, C. Oh, they're getting an interesting number there I didn't know about. Band readings taken with band switch at C. Here we are. These are all the things I got to do. Readings taken with band switch at C. Marker and oscillator dials full clockwise. Marker amp horizontal phase about half open. All other controls fully counterclockwise. Yeah, that's kind of silly for me to not have done this. But I think I have mentioned a number of times this whole thing is an iterative process. And maybe that's because it takes me many times around to get everything. If I ever get everything. Do you ever get everything? Okay, setting the settings correctly. Band switch at C. Band switch at C. Marker and oscillator dials fully clockwise. Marker and oscillator dials. Marker. Ooh. And oscillator dials fully clockwise. I think I must be talking about this. Fully clockwise. Marker amp and horizontal phase about half open. Marker amp and horizontal phase about half open. Okay. All other controls fully counterclockwise. Sweep width. Fine attenuator. What did I say? Clockwise? Counterclockwise. That would be it. That would be it. Okay, now we're ready to go. Now we'll see if that made any difference. Any difference at all. Meter. Okay, this voltage here still goes right over. It's supposed to be a 150. Goes over. And the other one, was that really a 150? The other one should be 100 on pin 6. This is 6 again. This is pin 6. And we get more. No, we don't. No, we don't. We're still low at 40. Okay, so we got 40 here, and we're supposed to have 100. That's a big difference. I'm just double checking all this. If I put this on the 50 volt scale and we make a reading, we should see 40. Yeah, 42. 40 instead of 100. Changing those settings didn't make any difference. 40 instead of 100. Now you're supposed to have 210 on the 12AT7. This may be coming from the same source of supply. Let's just jump up to the 12AT7 and look on pin 6 of the 12AT7. Where's that to? 12AT7. That's the 12AX7 here. So the AT7 is this guy down here, which is I'm pulling all my wires tight here. Way down there. AT7. We're looking on pin number 6 to see if there's 210 volts there. I'll leave this on the 150 volt scale. If it's 210, we'll know. Pin number 6. Okay, so I'm looking down here at the tube. 1, 2, 3, 4, 5, 6. Pin 6. Okay, pin 6. That'd be pin 6. Oh, this went the wrong way. That's not pin 6. Let's try it again. 1, 2, 3, 4, 5. Yeah, that was not 6. This is 6. Pin 6. Way over. So it's got its voltage. Now it's got its voltage there. I'm just guessing those two are coming from the same area. They're both screen voltages, so I think they're both screen voltages. One is okay, the other one is way short. What's going on with the 6CL6? What is going on with the 6CL6 that could cause that? So we're finding the voltage here to be way low. Okay, so one possibility is this resistor may have gone high. It's a 2-watt resistor. So we've got to find that and check it. Off of pin 3. Off of pin 3 on the 6L6. Pin 3 on the 6L6. Pin 3, and the resistor is that great big one that I've been testing around. 6.8K. So it's blue, gray, red. 6.8K, that's it for sure. This guy needs to be checked. Okay, power off. How hot did this thing get in the meantime? Got warmer. Definitely got warmer. How much warmer it would get, I don't know. We're going to read the, first we're going to check for voltage there in case there's something hanging around. Nothing hanging around. Let me just put it right down low here. There's a little bit hanging around there. A little bit here. Same on both sides. Let's just put the ohmmeter on it and see what we end up with here. It looks really nice. Yeah, the set, you know, my experience of it is it was working kind of, I don't know how well it was working. It was producing a sweep output and then it wasn't. That was my experience because I left the room, and when I came back it was gone. Is that really what happened? Did this thing suddenly disappear? Did it slowly die away? I missed the opportunity to see that. So this resistor we are testing. Okay, meter, you're going to act up on me now today? Going to be a friendly meter? You're going to be a troublemaker? Okay, across the resistor in the circuit. This crazy meter. Don't act up now. Too much voltage on here still? It's supposed to be a 6,000 ohm resistor. I got it on a 2,000 ohm scale here for some stupid reason, but you know, like if I'm not troubleshooting I'm troubleshooting all my instruments at the same time and doing all this work. Zero. Come on. How do you get a zero on that? How do you possibly get a zero on that? How do you get a zero now? You got to get another meter. This one's just becoming totally unreliable. There we are. Hey, 8.3. Finally got a reading that I like. It's supposed to be 6.8, it's measuring at 8.3. 6.8 is almost 7, 8.3 is almost 8. So now it's about 15 to 20% high. And that resistor, once again I'm losing my mind. There it is there. Could that amount throw everything off? You know, this is some kind of a regulator tube. I measured that guy okay. Didn't bother measuring him. This guy's reading a little high. You know, I think maybe I should change this. 6.8. It's not very convincing that would cause a problem, but maybe if you unbalance this a little bit, it ends up unbalancing everything terribly. What else could be wrong here? So I am reading 40 here instead of what I'm supposed to read. So and here I'm reading what I should read. The only thing in between is that resistor. Okay, that guy's got to go. 6.8K, 2 watts. 6.8K, 2 watts. Okay, I'm going to dig up the part here. Well, I don't have a simple direct replacement for it, but I've got two. I've got a whole bunch of these. 2 watt 33K resistors. They test, I've got a bunch of them, but the two I've tested here, they test at 3.4K. 3.4K is 6.8. It's exactly what I'm looking for. So I'm going to take these two, put them in series, put them in there, lots of room to do this, and you know, that's a better, not that I think this was getting hot at all, but this arrangement was much cooler. But okay, I'll put that in there. So I've changed the resistor there, but I give this only a 5% chance of fixing this thing. It's really hard to believe that the resistor can be a little bit out there and this whole thing wouldn't work on any band under any conditions. It's just a little far-fetched. But at least we'll eliminate this as a possibility. So there's the combination I've installed there. And I think we're ready to go. To try to figure out if this is working, all I'm going to do is try to tune it in on that radio there. Okay, let's switch on through the dim bulbs. .107 volts through the dim bulbs. There's not much current being drawn here this time. 100, 95, 92. Look at the currents coming up here. Once a B plus comes up, one of these tubes is conducting heavily. I think that's what that might be telling us. The wattage is around 40. watts according to this, but that includes these guys here who are dissipating a bit of power too. Okay, can we hear this on my little radio? Let's find out. I doubt it. So we're tuned to 100 megahertz here, and I've got the output laying right by the radio. That's the radio's antenna. The attenuator is halfway. The other attenuator is set to ×1, so no attenuation. Is that what that really means? ×1? Well, we'll try both settings. We'll find out which way they've done it here. Because that's okay. Here we go. So I'm going to set the oscillator frequency and try to hit 100. I thought I heard something there. And the answer is no. So this test suggests no output. So let's try another test. That was the easy one. We'll try another test here. I'll look on the oscilloscope for the signal coming out and going down to the fine attenuator. So we should be able to pick it up on the fine attenuator. Grounding this. I think the scope needs to be on for it to work. You need to be looking up this way a little bit. Okay. Scope sweep is the scope's own sweep. Okay, and the output is going to be right on this big resistor here. Right there, right there, right there. Okay, bury this, bury everything. Make this more sensitive. My scope is very sensitive. Any signal would blow it right off. This is the ×1, ×10 thing. Nothing happening. Turning every knob I can turn. Hey, now, there's a small change there. When I turn on the marker oscillator, or amplifier is what it says here. You see, a little bit of RF makes that line just a wee bit fatter. And fooling with this control does stuff. So I think there's probably a little bit of output coming from that extra circuit, making it down here. Maybe not. I don't know. It's just thoughts are just rolling through my head here rapidly. One thought is, well, this didn't help at all. So 5% was correct. 5% didn't do it. What's the voltage there now, Jim? Jim. What's the voltage, Jim? Okay, so we're on the 150 volt scale, positive upscale. And the voltage is, wait a minute here. Yeah, 6.8, yeah. Okay, supplying end of the 6.8, more than 150 volts. Delivering end of the 6.8. Hey, oh, that's only 40. It's exactly 40 again. Okay, so that's not surprising, is it? 40. I'm getting 40 volts on pin 3 of the 6CL6. 40 volts on pin 3 of the 6CL6. 6CL6. I say pin 3. Pin 3. Pin 3 is supposed to have 150 volts. How did I get that wrong? Pin 3, 150 volts. Pin 3 has the resistor on it. Why did I think this was only supposed to be 100? Who knows? Well, so incorrect grid voltage could be a problem. So we'll measure that, and that's on 2 and 9. We'll go there. 2 and 9. Okay, we'll switch this to a negative upscale reading. Pins 2 or 9 on the 6L6. 2 or 9. pins 2. Pin 2 has a resistor on it, which is brown, black, green. So that's 1, 0, 5 more zeros. So let's say 1 megohm, is it? And I'll be looking for that. I'm just verifying what I'm doing. Yeah, wrong tube, wrong tube. No, it's the right tube. It's the other side of the resistor. If you can follow what I'm saying, I'm impressed. Really impressed. I'm having trouble following what's coming out of my mouth. So up here on pin 2, we should see minus something. That's a pretty high voltage there. Has this tube been cut off? Oh my gosh. So the voltage there, I didn't notice this before. Oh, that's a 15 volt scale. It's not quite as bad as I thought. The voltage we're getting there is 13 volts negative. 13 volts negative. Now, what do they want there? How am I supposed to figure that one out? Oh, it'll be on the chart, Jim. So that's pin 2 or 9 on the chart. 6CL6. See, I should have printed this chart out. You know, when you're doing this work, you get all kinds of ideas. Oh, I should have done that. I should have done this. It would be an easier. Yeah, but those are all things, you know, everybody has great hindsight, including me. So 6L6. Yeah, I shouldn't have said that because now I forgot what I'm doing. Oh boy. 6L6 should be minus 2. Oh, minus 2 there. Minus 2 on the 6L6. And they show it on pin 2. They show it again on pin 9. Okay, well, we'll do it again. Pin 2. "15-volt scale, 13 volts instead of 2.4. So the tube's in cutoff. I think we might have found something significant here. So it's 2 and 8, 2 and it doesn't really show it here. Yeah, 2 and 9. What's going on there? One, 2, 3, 4, 5, 6, 7, 8, 9. So 9 has this big capacitor on it. 0.25. Yeah, okay, that's what they've done. So they've made a connection to 2 and a different connection to 9, just utilizing the stuff in here. So, oh, now that can make it go high. That can make it go low. So how do you get it high? How do you get a high voltage here? So the voltage is coming through these resistors, or coming through this resistor. Oh boy, coming from the plate of this. This is a complicated little guy here. This is a one-of-a-kind circuit. Some extremely clever engineer thought this up. This is the blanking tube, although I don't like the word blanking. It's called the zeroing tube. This manages to zero the signal during the retrace on the scope, bring the signal down to 0. And it does it in a very complicated way by fooling around with cutting off tubes, supplying voltages that cut tubes off. If I remember right, I'd have to read it all again. Probably read it again a couple times to really understand what they're up to here. So this is supposed to be a level control, and this is supposed to be a blanker. But the plate is connected right to the grid of this. I have to do some reading here. So how does this plate get a voltage? It gets it from, it gets it from here through the 1 meg. Oh yeah. So here's the plate voltage through a 1 meg resistor. So this would go high. You get less and less voltage Here, how do you even get a negative voltage from this plate? Okay, I'm going to stop and read up because this just isn't, this is a very unusual circuit here that they've done. You know, when you work on a radio, everything is kind of in the same lane. It doesn't matter who engineered the radio, it's all kind of the same, more or less. But when you get to an instrument like this, yeah. Okay, I'm going to go read up, get smarter. I need to get smarter. Well, after reading up, okay, I understand the circuit a little bit better. What I'm going to do, last thing I'm going to do here today is I'm going to test the 6BQ7. This is the tube that's responsible for oscillations in the sweep oscillator. You know what I just did? I just knocked that terminal strip off. This one here. No, it's still on. Okay. 6BQ7A, made in USA, Tungesal. So I did test all the tubes early on, but the main thing I was doing there was making sure that the tubes worked, that there wasn't a dead tube. No, there weren't any dead tubes. Let's see if I can get the lighting a little bit better here. Okay, 6B, that's not good for you, not good for me. 6BQ6. Can anybody read that? 6BQ6, 6BTQRST, 6BQ7. Right. 6BQ7. Double check everything. 6BQ7, 6.3 volts. Let's turn it on. 6.3 volts, 4 signal level, 17L. This is suspiciously PGK76. PGK76. 3510. 3510. D for the plate. Ready to go. Now this is a two-part tube. It's two, is it two triodes in there? I think it's two triodes. Two something in there. So one side could be strong, the other side could be weak. Now in some cases when you use a tube in an oscillator, it works very hard in the oscillator and it wears out. Or it might not, the same tube might not wear out quickly in other applications. Oscillators can be tough. Only two. Yeah, that thing is just glowing like a son of a gun, isn't it? Wow. It's definitely on 6. It seems unusually bright. Okay, any shorts? Oh, look at this. We've got a little bit of leakage on the first setting. Remember that. A little wee bit. I think I made a note of that, in fact, on my note sheet, which I then did not bother reading. I'm just checking here on my note sheet. 6BQ7 tests 5 mega ohms short on 5 settings. We're on the 5 setting, and there's the short. Could that be enough? I don't know. We'll give it a test now. 6BQ7, 12. You see a 1380, almost 1400, so just about straight up is where it needs to go. Wow, that went right over. Okay, and then we flip to the other half of the tube that way. What is going on here? This tube is glowing like a son of a gun. It's reading extra high. Let me just knock this down a notch. Knock it back up. I don't get it. It's really, really bright. And it's testing super duper good. Super duper good can be a problem. but I don't think this is in the problem range. Maybe it's testing super good. I just got a bit of a leak on it. Oh, time for another tube. Time for another tube. 6BQ7. Okay, let me hump one down. Okay, well, I got a few 6BQ7s, that's for sure. These are all tested in the sense that they all work. Do they work well? I don't know. So we're going to take this one out. I'm going to put it right with the radio, because I have a habit of confusing all these out here. Let's see, this definitely says 6BQ7. Definitely. Come on, stick it in there. How bright does that one get? Not very bright. Kind of reminds me of myself. Okay, that looks dead. Oh no, it's lit. It's lit, but it's not lit crazy like that last one. How strange is that? Okay, here we go. Okay, no leak appearing on setting 5, so it's different than the last one. GM test, and we are shooting again for 1400 basically, which is pretty much straight up. Right over. Okay, and then we test the other side. Not quite right over, but pretty close. So that's 2 of these tubes testing high. Maybe this tester tests this tube high. Let's try another one. I have a bunch. We'll try another. You mean remove this one here? Will it go? (6BQ7). This one's lighting up fairly bright. And it's interesting, that some of them don't light as bright as others. Okay, leak test. No leaks apparent. GM. Right over. Right over. Well, we got a couple here to try as an alternative, because when you're fooling around with oscillators, some other problem could be happening in the tube that's setting it off. Okay, so either one of these, we'll put this guy in here. That's very hard to see. Very hard to see. This is one of those flat, totally flat tube sockets, so there's nothing helping you get the pins in. Okay, so this original one I'm going to put over here somewhere, and this other one I'm going to put on the tube. No, I'm going to put back in the bag. That's the best thing to do. I do not want to get confused here. Okay, now what are we scoping? So we're scoping the output of the sweep. We should see it up there if it shows up. Are we ready? We're ready. Everything ready? All I did was change the tube. Power on, power on, power on. So the initial flash here is from charging up capacitors. And then when it'll come up here again, it'll be because of tube current. 108 volts, 107, 105, going down. 90, 90, going down. 80, okay, we'll give it full power now. There's something on the scope here. It's not what I would expect. Let me fool around here now. We'll just turn some controls around. Let's change the band setting. No, it's not very reassuring at all. 10 Attenuators, it can't be that. A frequency setting. Oh, there is something going on in there. Oh, yikes, what's that? Well, this is pretty interesting now. Pile of spikes. So that could be part of the blanking system. It's hard for you to see it. Let me just go up one speed. So there you can see them better. So you see these marks here are probably I don't know what they are. I mean, I'm just taking a wild guess here. It's a shot up, and it's a shot down, and it's a shot up and a shot down. Huh. They just add that to the pile of information here. What setting could I have that might be doing this that I haven't really fooled with yet? Sweep width, nothing happening there. Why don't we look at the output right on the actual output? Why don't we do that? That might be a smart idea. Maybe where I've picked it off, it's not really what I think it is. Okay, so we'll take this out, which I can't imagine how it can't be what I think it is, but you never know. So we'll go on ground here. The output. Wow, it doesn't look very good, does it? Excuse me. Attenuators. Around 0.2 volts per division here. Nothing is doing anything. How about band change? Band change. She doesn't. She doesn't. How about we put this on ×1? Help my scope out a bit. Make it more sensitive. Any of those funny peak things showing up? No, I don't think so. She doesn't. Oh. Huh. Well. So the thing I'm finding is the voltage, let's just repeat this, the voltage at the screen, hey, where'd the booklet go? Ah, I've left it somewhere. The voltage at the screen is supposed to be 100 if I remember right, and it's only 40. Ah, well. Oh well. Well. Yeah. Okay, so I think I'm going to cut it here because I'm totally befuddled, and it's well after lunch and other things to do today. So unfortunately we didn't really get anywhere here, but so be it. Hey, thanks a lot for watching this series. See ya.